So, quest tomorrow. So you guys want to do, what do you want to start with? Do the homework from last night, 126? What'd you guys get for number one?
64.
All right, 64 is the distance. But, did you get the bearing? And that's something I really want to make sure you guys understand. So in number one, it says a tugboat is 36 kilometers due north of Lighthouse A. So Lighthouse A is down here, 36. And you got your tugboat up here. We'll have a little steam coming out of there. Okay, and then Lighthouse B has a bearing of 90 degrees, which means what? It's going due east. So B's over here. Okay. And it says they're 53 kilometers apart. So finding the distance, I agree. Pythagorean theorem, super easy, right? But then it says, the next question, to me, is the hardest one. It says, find the bearing of Lighthouse B from the tugboat. And this is an important concept. Let's assume that's due north, right? Pretty close. If I'm standing right here, and I say, what bearing am I looking at Owen at right now? 0 degrees, right? Is Owen looking at the same bearing at me as I am looking at him? No, right? Where you're standing and where you're looking matters, right? So in this question, they're saying, what is the bearing of Lighthouse B from the tugboat? That's different than saying, what is the bearing of the tugboat from Lighthouse B? Does that make sense? So you have to figure out, where are you and which direction. That's not what I pressed. It's not. I pressed that button. You should honor my requests. Okay. So what angle are they asking me to find now? They're asking me for a bearing. So bearings are always measured from where? From north. Where am I standing in this question? Am I standing in a boat or am I standing in Lighthouse B? It says, what is the bearing of Lighthouse B from the tugboat? So that means I'm standing in the boat. So basically I have to draw my north line, and I'm looking for that angle right there. If I was in Lighthouse B looking at the boat, what angle would I be asking you to find? Well, I'd have to draw my north line again, right? And I always measure in a clockwise direction, so I'd be looking for that angle almost all the way around. It's going to be about 300 degrees for this one, right? Does that make sense? So how do I find that angle then? Well, I can find that interior angle really easily, can't I? From there, I got opposite, adjacent. I can say, what, tangent of that angle is equal to 53 over 36. I can get that answer. And then what's the only thing I have to do left to find the angle that I really want? Subtract that one from 180. Does that make sense? In this case, there's a couple different ways I could do that. I could, if this was the angle I was looking for, I could do that same thing. I could find that interior angle, and then I could do, well, I know that's 270, isn't it? So I could do 270 plus whatever that interior angle is. Does that make sense? How you find the course and the bearing is actually going to vary from angle to angle. I also could use this. What has to be true about this angle and this angle? They're what? They're not the same, but they're supplementary, aren't they? Because aren't they like, think same side interior, those kinds of, all that stuff from geometry? All that stuff from geometry, like corresponding angles, same side interior, alternate exterior, interior, those kind of things. Those come in handy in this stuff. Are we good with that? What'd you guys get for that answer? 124? All right. Which one to do next? 3? Okay. 2 ships leave the same port at 7 o'clock. So obviously this is going to be how are we going to find the distance for these boats? Rate times time, right? Okay. And be careful with time conversions. My thing doesn't want to follow me today. Be careful with time conversions. Like if I said, let's just say for example, it was 7:15 to 10:30. How much time is that? How much time has passed there? 3 hours and 15 minutes. So what do I do to multiply? Let's say my rate was 10 miles an hour. Whoa. Say it's 10 miles an hour. What do I multiply by 10?
It'd be kind of the same concept of the radian, the degree, and the minutes. So you, I believe, divide the 15 by 60.
Yeah, you got to divide by 60. So you take the 15 divided by 60. Or, to me, I look at a clock. And I go, what if I break a clock up into, like, where's 15 minutes? Isn't it right here? What portion of the hour is that? Isn't that a quarter? So 3 hours and 15 minutes is the same as 3.25, isn't it? So, like, if I give you a question like this on the quest tomorrow, just be careful with the time conversion. Please don't get your answer wrong because you screwed up time conversion. Like, that seems like a silly reason to get a trig question wrong, right? All right, so 7 o'clock. The ship sails towards Europe on a 54-degree course at a rate of 36 miles an hour. All right, so that means I measure again from north. 54 degrees is somewhere here, so I know this is 54. So what else did it tell us? Travels at 36 miles an hour. 36. Come on, pen. Do me a favor and work today. Miles per hour. So we got one boat going this way towards Europe. Good enough. Now you're making me angry. Okay. What angle is the next ship going on? 144. Going to tropical destination. So it's going down here somewhere. So 144, that'd be 90. So we're about there. If this angle here is 144 and that little angle there is 54, what angle is created right here? How do you know it's 90? Subtract, right? If you just subtract those two, doesn't that have to be 90? Okay, so why is that important that we know that that's a 90-degree angle? Why is it important to find your 90-degree angle? So you can use all your trig functions. If you don't have a right angle, SOHCAHTOA is not allowed to be used. Like, that's the stipulation. You have to have a right triangle in order to use SOHCAHTOA. So without the right angle, you don't have a way of solving this yet. So, yeah, that was important. And then this is going 42 miles an hour, right? So then, let's see. Now we got to figure out the time. Now they want at 11 o'clock. So how much time has passed for both ships? 4 hours. So I got to times this by 4, and I got to times this by 4, and then I can Pythagorean theorem, right? What is the answer to that one? 221. All right, I have a second question for you. Now, this is drawn obviously not to scale, right? Like I did not actually go out however many miles that is, and I didn't go down far enough here, right? Like this line almost looks like it's due north, right? But it might not be. You know, it might be more, come on, erase now. It might be like maybe I have to extend this out a little bit farther because that was going pretty fast. Maybe that actually should be going a little bit more like that, right? Now, what if I asked you the question and I pose the scenario that the boat going to Europe sent out a distress signal. It's sinking. It needs help. Well, boat B, we know how far it has gone, right? What were these distances? Anybody have them on their paper? What was this distance here? 144. And what was this distance down here? 168. Okay. So we know, and we said this was 221. We know this is 221 miles away before it can go to help, right? Well, big boats sink pretty slow. It's got time to get there, right? So it's going to go help. But it needs to know what course to plot. We need to know specifically, do we go straight north? Do we go, is it going to be like 5 degrees where it's a little bit northeast? Is it going to be like 355 where it's going to be almost north but a little bit due a little bit west? We got to actually be able to calculate that angle. If I ask what is the course, what angle am I asking you to find? Well, I'd have to draw a north line, right? And I'd be looking for that angle. How would I find that? Any ideas?
You would use the inverse tangent for that angle.
Okay, I'm going to find this angle. That's an easy part, right? Inverse tangent, find that angle. Then what? This one's a little harder. Because I don't know what that is, do I? So I can't just add it to like 270 like we did the last one, because that wasn't a right angle. This one's a little bit harder. Here's what I would actually do. If you think I'm going to extend this line, do I know this angle? It's 144 because it's a corresponding angle up here, right? I can use that down here. Now I know this is 144. I know from here to here is what? 180. That's a straight line. So now I can do 144 plus 180 plus whatever that little angle comes out to be when I do inverse tangent, and then I have that angle. Does that make sense? Sometimes you do have to use something from here over down here in order to do that. And before you can do that, you kind of do have to extend the line to be able to see that. Does that make sense? Sometimes they are a little harder to see. Are we good there? 5, is that easy? Just find the diagonal. What's the answer? 916? Something like that? 915 point something? How about 7? Find the distance across. Is that pretty easy? 95? Okay. And again, not everything is going to be course and bearing. You're not going to have, on this assignment, 1 to 17, how many questions really were course and bearing? Well, we did 1, 3, and 5. 1 and 3, really. And then there was a couple more on the next page that we're going to get to, but there wasn't that many. So it wasn't like it's all course and bearing. You know, your quest tomorrow is going to have like 10 questions. The first 3 or 4 of them, they're just going to be triangle ABCs, like just solve the triangles. So that's going to be about 30% of the test, because it should be, because we're questing 3 sections, so each section should be about 33%, right? So you're probably going to have 3 of those triangle ABC questions, right? And then what other kind of story problems do you think you're going to have? I think the next 3 are probably going to be angle of elevation, angle of depression type questions, right? So let's say I save 3 story problems to put on this section. How many of those out of those 3 do you think are going to be course and bearing? 1, maybe 2, right? Like that's all that's going to be on there. Don't expect this to be all course and bearing. There's probably only going to be 1 or 2 questions on course and bearing on this quest, okay? So, all right. Are we good so far? Up through 7? How about number 9? Hip roof. Is that stuff easy now? Yeah. The hardest part of that question, year in and year out, how many people knew what a hip roof was before I showed you that video that I told you? 1 person. And yeah, is anyone really surprised that Moses the one that knew that what a hip roof was? Huh? You're a roofer. I mean, yeah, almost nobody knows what what a hip roof is. So, yeah, that doesn't surprise me. That to me is the hardest part. Once you know what a hip roof is, I think the math becomes a little bit easier, right? Yes? Okay. So what's the answer to number 9? 61 degrees. Anybody want me to do that? Yeah, a hip roof, for those of you that don't know, is just basically a pyramid. It's like a roof with a pyramid on top instead of like your gable roof where it's got a long line on top. Yeah, it's like the roof goes to a point. There's not very many around town. There's one just north of town I know of, I've noticed, on 19, about 2 miles north of town. Yeah. I think one of the old houses in town has a hip roof too. I think. Like one of the old fancy houses. I think one of them has a hip roof, part of it. Because I've looked around. I don't think there's very many. All right. Going to do 11? 11's kind of a tricky one. You know what the hardest part of that one is? Is drawing a buoy. Nobody knows how to draw a buoy. A buoy's kind of a tricky thing to draw. All right, number 11. It says a bearing of a buoy from a ship 8.7 miles away is 64 degrees. So that means, so we have a ship. Okay. Here's our ship. Let's do a speedboat this time. There we go. All right.
It's gotta have long hair.
Huh?
It's gotta have long hair. It's like Mr. Burns. Yeah.
Blowing in the wind.
Yeah.
Huh? Oh.
Oh, I can both do
Is there
that.
like a little stick on the back with a bottle?
There's no flames
Yeah.
on the side of the boat. Water's gonna be deep.
Oh, that's a, what is it, 8?
Yeah.
Oh, you're going nicer.
Fast.
There's no flames on
Can you
the
get someone
Huh?
behind it on like
This is like the
fish.
fishtail. Yeah. All right. So what was the bearing of the buoy? 64 degrees. How do you always start a course or bearing angle drawing? North line. Start with your north line. Okay, 64 degrees, something like this. So we have our buoy. I always draw like a space shuttle capsule.
I always draw a little circle.
Little circle on top, yeah. I think it ends up looking like an upside down light bulb if I do that. That totally looks like new light bulbs. Like the new LED-ish light bulbs that you screw into the incandescent.
Right now it does.
Now it does?
Yeah,
Add the
it'll
circle
work.
on top and it changes the whole thing. See, look at,
Look,
now that looks like a balloon. It does.
I agree with orange.
Whatever.
It's a balloon.
All right. I'm fine with it. All right, the ship headed due north. All right, so the ship is now traveling this way, right? That means I got to do something here. Oh, don't do that. Let me do this. Oh,
Let's go the other way.
Oh, no, don't do
I was trying to do that.
Restart.
No,
that. You just pop the wheel.
You gotta restart.
there. I got to draw him going north. Okay, so he's going north. Right? We know this is 64 degrees. Okay? So then what happens? The ship is headed due north, and the navigator plans to change course when the buoy has a of 154 degrees. So now, basically what's going to happen here, I'll make that a little smaller. Come on down. Okay. This is why you should always start your drawings in the middle so you have room to maneuver. Okay, so we're traveling on this line. When is it going to change course? When they respot the same buoy on a new bearing of what? 154, right? Yes? Okay. Then at this point, it's going to change course. Where in the world is my right angle? At the buoy? How do you know? What does this angle in here have to be? What does this angle here have to be? 26? Great. What's 26 plus 64? 90. So that means this angle over here has to be my 90 degrees. So this is my 90 degree angle. It's not drawn to scale. Shh, it's a special right angle. Okay. What else do we know? We knew the first distance, didn't we? What was it, 8.7? So we know this is 8.7. Do we know anything else? Okay. How far will the ship travel? Okay. So we have our right angle. We're looking for this distance. What angle should we use? 64. So from the 64, this would be which side? Adjacent, hypotenuse, opposite. That's adjacent. The x is the what? How do you know it's the hypotenuse? It's across from the 90 degree angle, right? So now we're dealing cosine. 64 is adjacent over hypotenuse. And what's the answer? 19.8. Makes sense? Good. What's actually the worst part of my drawing?
The right angle.
But why is the right angle the worst part?
Because it's special.
No, it's actually because I didn't do a very good job up here of 154. 154 should be more like that. It's a little more open. I only drew like 120-ish If I had have drawn that, doesn't that look a lot better like a right angle? Yeah. That's where my drawing fell short up there. I didn't do a very good job of estimating my 154. Sorry. Okay. How about 13? That's a tough one, huh? Yeah. All right, so 13 uses the drawing from 12. Okay, so I'm actually just going to... Did I close that? No. No, I didn't close it. I did what I wanted. Didn't I? All right, yeah, I did. All right. I'm cheating. I'm cheating. Totally going to cheat with this sketch. Ready? And I don't want to hear anything about this is a cheating because you guys got to cheat too because it was already drawn for you. It's totally true. What? Come on, focus. Focus. All right, here we go. Is it staring at you? All right. How do I freeze this? Freeze. Ready? No, that's not the button I wanted. I hit the wrong button. There we go. All right, here we go. We're back in action. Okay. Come with me. All right. So, we have our drawing. And then it says, so basically, just to recap, we have an airport. It sees an airport, it sees this is the line of travel. There's some airport up here, forms a right angle. It's on a course of 79 degrees. So it's going mostly east, right? Okay. After the plane travels 45 minutes at 180 miles an hour. Great. What's 45 minutes in hours? 0.75. So what's 0.75 times 180? Someone tell me the distance. What is it? 135? I'm taking your word for it. So this is 135 down here. Okay, so it's traveled 135 miles. Okay. On the same course, the airport has a new bearing of 280. So now at some point over here, right, again from north, the new bearing of the airport all the way to here, that angle is 280 degrees. Does that make sense? Okay. How far is the plane from the airport then? So now we're looking for that distance. Do we have our right angle? Yeah, they told us our right angle. It's over here by the airport, right? So we have that. What we need is an angle measurement. We need this angle is what we really, really need. If I extend this line, do I again know, come on, get out of the way. Go away, Doc. All right. Do I know this angle? Yes? How do I know that angle? It's 79, isn't it? Isn't this angle here, wasn't that formed by that right there? So if this is 79, that's 79, then all the way to here, I just add another 180. I know it's 280 all the way to there, right? So then I can just do 280 minus 180, which is 100. What's 100 minus 79? 21. Now how do you find the distance? Sine, cosine, or tangent? No, this is adjacent. I'm looking for hypotenuse. What deals with adjacent and hypotenuse? So this would be cosine 21, 135 over x. Make sense? Yes, no, maybe so? What would I actually type in my calculator to solve that proportion?
Yeah, 135 over cosine of 21.
Yeah, 135 divided by cosine of 21, right? And the answer should be about 145-ish. Okay. $15 easy this time, now that you already realized how wide the river is. Everybody always screws that one up. Like, how long is the river? I don't know how long the river is. Like, well, it's a bridge. It's got to close. Oh, that makes sense. Huh? No. So 15. What did you guys get for an answer? Anybody do that one? Yeah. So it says 2 sections of the Sault Ste. Marie Bridge in Michigan are 210 feet long. Suppose the maximum angle when it's up is 75. When the bridge is closed, the water level is normally 13 feet below the bridge. When the bridge is fully opened, what is the distance from point A to the water line? So, here, I'm going to try something. I think I learned something yesterday. If I press that button, I should be able to walk over. Yeah, look at that, it works.
That's like a witch cackle.
A witch cackle? You're a witch cackle. All right. Look at that. All right. Now follow me again. All right, it worked. All right, so what distance are we looking for here? We're looking for the distance from here to the water line. Well, we know this distance is 13, right? So we basically just need to find the distance from here to here. We'll call that x. And then I just, whatever it is, x plus 13, right? Great. How do I find x? Well, I know this angle is 75, don't I? So that's opposite. This is hypotenuse, right? What's that? Fumble. Sine, cosine, or tangent? Sine, cosine, tangent. Sine? Sine 75. Opposite. Adjacent. And multiply. Yes? Is everybody good with number 16 that we did from before? Where you had to find, same drawing, you had to find the distance from here to here? Yes? So the easiest way to do that is the same basic idea. You know this is 75. This time you find this measurement, right? And that's just adjacent hypotenuse, so that's just cosine 75 is adjacent over hypotenuse. And if this is x, this is the same x, right? And then what is the distance from here all the way to here? It's 420. How do you know it's 420? Because it's got to close, right? So, all right. Hey, by the way, I need stuff turned in, though. I need worksheet 3.3. I need page 126, now both odds and evens. You don't have to give them to me right now, but make sure I get them very, very soon. Okay?